Hey guys, this is Mrs. Tran-Bloom. Now I keep forgetting that other math teachers, other pre-calculus math teachers are also using this video note. So I should tell you guys who I am, right? I'm Mrs. Tran-Bloom. I teach pre-calculus and pre-calc honors. I'm that one Asian teacher, that walks around campus. Sometimes I dress up like a teacher and sometimes I don't. So that's me. Anywho, and I tell, you know, toddler jokes that about 4-year-olds. I have triplets. They are 4, so I have a lot of toddlers, joke to tell. So if it sounds kind of corny, it is because it is, right? That's why that's why they're called toddler jokes. Anywho, so talk about jokes. Let's give you one. Okay. Why did the obtuse angle go to the beach? So why did the obtuse angle go to the beach? Because it's over 90 degrees. Ha ha ha. See? That's my 4-year-old. Anywho, let's start with example 2. Using transformations or key points to graph the following for at least 2 cycles, state the domain and range, determine the period and amplitude. So most of the time, you're going to be graphing 2 full cycles. This is what your textbook does, and this is what I'm going to be asking you on exams. So let's practice, okay? You can graph it 2 cycles to the right, 1 cycle on the right, 1 cycle on the left. It doesn't really matter. Now, I am going away from stages, so I'm just going to use key points. Okay, key points mean I'm going to graph one final graph here. So let's talk about f of x equals 3 times sine of x. We have one transformation here, which is the 3. But let's first talk about the period and amplitude. Period equals 2 pi divided by absolute value of b. Well, this is 3 times sine of 1x. There's 1 in front of x, so there's really no horizontal changes. So it's going to be 2 pi divided by absolute value of 1, because there's a 1 in front of x. So this is going to be a period 2 pi. Oops, I should write 2 pi correctly. So period of 2 pi. That means it's going to repeat every 2 pi distance, horizontal distance. Okay, so since I'm graphing 2 full cycles, I should have 4 pi total. So each period you should have each period you should have 4 equal intervals. So half of 2 pi is going to end up of a pi. Half of pi is going to be a pi over 2. So each tick mark is worth a pi over 2 unit, okay, radian. So again, 4 equal intervals. Between 2 pi and 4 pi, there should be 3 pi. So this is pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, reduces down to 2 pi, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, reduces down to 4 pi. So they have to be consistent, okay? So that's the period. We can talk about the amplitude as well. Amplitude is absolute value of a. We have the vertical change, which is 3, so it's going to be absolute value of 3, which comes out to be 3. So that means I'm going to go up 3 units from the center and 3 units down from the center. So my parent function, is going to be f of x equals 3 sine, oops, I'm sorry, not 3. Parent function is nothing, no changes in vertical, horizontal, so just simply sine of x. Let's quickly make an input and output table for your parent. By now, hopefully, we have the input values in. So you have 5 input values, right? A handful. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Then we have the outputs. Sine of 0 is going to be 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And sine of 2 pi is back at 0. Now you have a transformation 1, a vertical stretch factor of 3. So the x is going to stay unchanged, but your y is going to be multiplying by 3. So whatever y is, we're going to multiply by 3. So your output is going to be input, because there's no changes in the horizontal, that's going to stay the same. So your output is going to be 3 times whatever the parent function was. So 0 stays as 0, pi over 2, all the inputs remain unchanged. Okay, so those are my inputs. 3 times 0 is 0, 3 times 1 is 1, 3 times 0 is 0, 3 times negative 1 is negative 1, 3 times 0 is back at 0. So these are the points that I'm going to use for graphing. So 0, comma 0, pi over 2, comma 1, which is the first tick mark. Oops, I'm sorry. Pi over 3. I forgot to multiply by 3. Duh. Right? Alright, 3 times 1 is 3. 3 times negative 1 is negative 3. Oh my goodness, this Asian teacher. Anywho, I'm going to plot pi over 2 comma 3. There you go. Pi comma 0. I sound kind of funny because I'm sick. 3 pi over 2 comma negative 3. But even when I'm not sick, since I'm Asian, I sound kind of funny naturally anyway, right? Okay, so those are my dots. Looks, I have 5 dots. So connect my dots. Okay. Now we're going to need arrows on the two ends. Just because I'm asking you to graph for 2 full cycles doesn't mean the sine curve stops at 2 full cycles. It's going to go on forever. It repeats forever. Okay? So to continue, looks like we're both ending and starting at 0. So the next one's going to go up at 3, staying at 0, go down negative 3, and back at staying 0. So this is cycle number 2. Okay, put an arrow. So that's the arrow at the end here, the arrow beginning. We are good to go. Alright, graph done. State the domain. Domain is going to be from negative infinity to infinity. State the range. We're going to have it from negative 1 to positive 1. The lowest one, I'm sorry, the lowest negative 1, the highest positive 1. And the amplitude and period, check and check. We are good. Okay, so domain, box it up. Range, box it up. We have a nice looking graph. We have a nice beautiful table. We are good. Okay. And now on the exam, I'm going to ask you, hey, what are all the values of x-intercept? Or what are all maximum values? What are the minimum values? So make sure you know how to write these using k. Okay, just like the parent function that we did before. Alright, let's move on to example B. Are you ready for example B? Okay. Here is example B. Oops. Alright. Example B, same exact direction. We're going to look for the period, which is 2 pi divided by absolute value of b. Now look at this one. We do have a horizontal change. This is a horizontal compression of a half. So we're going to go 2 pi divided by 2. The period for the parent function is 2 pi. If I'm going to compress it by half, it's going to end up, take 2 pi, cut it in half, it's going to be a pi, which mathematically, as you can tell, it makes sense, right? So this is horizontal compressed by a half, so therefore a period to pi. Amplitude is going to be absolute value of a. We have a negative 1 right here, so it's going to be a negative 1 inside my absolute value. Absolute value of negative 1 is 1. So my amplitude is still going to go up 1, and so the low is negative 1. Alright, parent function. Here we go. Alright, let's make a table. I mean, not a table, I'm sorry. Put this in our x-axis. So 1 full period, n at pi. If 2 full cycles, so 2 pi's. So 4 equal intervals, half of pi is going to be pi over 2. Half of pi over 2 is going to be pi over 4. So each tick mark is now worth a pi over 4. Alright. Between pi and 2 pi is going to be pi and a half, or 3 pi over 2. So we're going to do the parent function. And if you are not great at finding or making a table, input and output, then copy these down. Okay? By the end of the notes, you should be an expert and be able to do this really fast. You need a handful of values, right? 5. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. For the parent functions, even sine or cosine, doesn't really matter. These 5 inputs don't change. Okay, the outputs will change depending on if it's sine or cosine, but for the inputs, it's not going to change. All right, sine at 0 is 0. Sine of pi over 2 is 1. Sine of pi is going to be 0. Sine 3 pi over 2 is going to be negative 1, and sine of 2 pi is going to be 0. So that parent function should be identical to example A, right? There's no difference. It's put them next to each other. There's no difference in terms of parent function. So, and I know some of you don't want to write it again, but if I were you, I would just do it again. So by the end of our notes today, you are going to have it all down. All right. Transformations. We have two. The first one, it's a vertical change. So I'm going to reflect it about the x-axis. That means your y is going to change. Okay, so make my table. So I'm going to take all my y's and I'm going to multiply it by negative. So negative f of x. Reflect about the x-axis. If it's on the top, it's down the bottom. So the y values are changing. This is a horizontal compression of a half. Notice how all parent functions have a period of 2. When you compress it, it's now half the distance. So I'm going to take all my x values and multiply by a half. Okay, that's what it means to compress it by a half. 0 times a half is still 0. Pi over 2, that is the bell to go to 6th period. Okay, pi over 2 times 1/2 is going to be pi over 4. Pi times a half is going to be pi over 2. 3 pi over 2 times a half is 3 pi over 4. And 2 pi, half of 2 pi is going to be pi. This ending value should always, always, always match up with your period. Negative times a 0 is 0. Negative times a positive 1 is negative 1. Negative times 0 is 0. Negative times a negative 1 is positive 1. Negative times 0 is 0. So these are the values I'm going to use to plot. Here we go. Looks like my highest is at 1 and my lowest is negative 1. So here we go. 0 staying at 0. Pi over 4, negative 1. So here's pi over 4, put a negative 1. Pi over 2, staying at 0. At 3 pi over 4, go up at 1. And pi staying at 0. So notice how we reflected it about the x-axis. Now it's kind of upside down. And continue the pattern. So it looks like I'm going down, going back up at 0, going all the way up at 1, and staying at 0. So continue. Woo-hoo-hoo. Okay. Notice how I need arrows on the two ends. This one I can go up a little bit. This one I can go down a little bit. Therefore, those are my arrows. Okay. Now we're going to talk about the domain and range. Domain, it goes on forever. Negative infinity to infinity. Your range, how high and how low. What's your low and what's your high? My low is negative 1, inclusive, and my high is positive 1, inclusive. Alright, we got asymptote, we got period, we are good to go. No, sorry, not asymptote, amplitude. Alrighty. And don't forget to find, if you need to be able to find, hey, if I ask on the exam, find all values of your x-intercept, then that's when you are supposed to use your k equation, right? So look over at your notes on the parent function of how to find the equation for the intercept and the high and the low, alright? Alright, so C, f of x equals 2 times cosine of 3x. This is sort of combining your a and b together, but using it on cosine function, which I'm going to let you do that on your own. Okay, find the period, find the amplitude, find your parent table. So make a table for your parent. Okay, so period, figure out what that is, because you need to know how to make it. Find your amplitude. Parent function, I'll give it to you, y equals cosine of x. Put your 5 inputs in. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Find the output of the parent. Okay, find your output. Make another table for these two changes. This is a vertical change and this is a horizontal change, so you need to figure out what they are by looking back at A and B. And then once you're done with that, graph it out, find your domain, find your range, and you need to do this on your own. Alright. But, so go ahead and pause it and do it on your own, or you can complete that after I'm done with D. Okay, because D looks really scary, so I want to do D with you. Here we go. D for go and okay, here we go. Y equals 2 plus, ooh, there's a lot of stuff. 2 plus 5 over 3 times sine of negative 2 pi over 3x. That is totally scary looking. Alright, but don't be afraid. Math is our friend. So we're gonna rewrite this. I'm gonna write 5 over 3 times sine of a negative 2 pi over 3x, and then I'm gonna bring the 2 on the back, because this is really a vertical shift of 2 units up. Period and amplitude. Here we go. Amplitude, absolute value of A, and A happens to be 5 over 3, which is in front of sine here. So absolute value of 5 over 3 is simply 5 over 3. Period is going to be 2 pi divided by absolute value of B. B is going to be right here, the horizontal change. So we're going to do 2 pi divided by absolute value. I'm out of space. I'm writing division with the 2 dots. Divided by negative 2 pi over 3. Dividing, I'm going to change it to multiplication. So 2 pi times absolute value of any negative number is positive. So 3 now over 2 pi. Alright, like that. Oh, nice. Make that into a fraction. 2 pi and 2 pi would cancel each other out. So my period is just simply 3 units horizontally. Beautiful. I'm going to drink some water. Okay. So since I have to graph 2 full cycles, make that a 3. Make this a 6. Okay, half of 3 is 1.5, or 3 over 2. Remember 4 even intervals? So with 3, half of between this and that is going to be 4.5. 4.5, what is that, 9 over 2? 9 over 2. Half of that is 3/4. Okay, so each tick mark is 3/4. So 3/4, 6/4, which is reduced down to 3/2. Yeah, that makes sense. And then 2 more marks here, because 4 even intervals going on. So parent function, let's graph it, right? Y equals sine of x. Let's put in 5 inputs. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Outputs, f of x. Sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine 3 pi over 2 is negative 1. And sine 2 pi is back at 0. Alright, a bunch of changes. Here we go. This is a vertical change. So let's put it on the vertical, which is the output, right? This is a vertical stretch of 5 over 3. That's the bell for tardive 6th period if you're late. Alright, so 5 over 3 times y. That's a vertical stretch of 5/3. Okay, this is a vertical shift up, so I'm moving up by adding 2. This is a horizontal change, so let's talk about this piece. Inside is a reflection about the y-axis, so the x is going to change. I'm going to multiply the x by negative. In addition, this is 2 times pi. Now, pi is about 3.14. So even if we round it to about 3, which you don't want to, but because I don't have a calculator, I want to see if it's bigger than 1 or greater than 1. I'm sorry, bigger than 1 or greater than 1. That's the same thing. Bigger than 1 or smaller than 1. So 2 times 3 is 6. 6 divided by 3, that's greater than 1. Ignoring this negative sign for right now. If it's bigger than 1, it's a horizontal compression. And we flip it. So 3 over 2 pi, and then times x. Okay. So this is a horizontal compression of 3 over 2 pi. And then it's a reflection about the y-axis. So it's going to change your x. Alright, here we go. 0 times negative 3 over 2 pi is 0. Negative 3 over 2 pi times pi over 2. Okay, let's write that over here. Pi over 2 times negative 3 over 2 pi. I know things will cancel. Pi and pi will cancel, so it becomes negative 3 over 4. That's what I have. Then pi times a negative 3 over 2 is going to, the pi and the pi will cancel, so I'm end up with a negative 3 over 2. 3 pi over 2 times a negative 3 over 2 pi. Let's see what happened. 3 pi over 2 times negative 3 over 2 pi. those pi's will cancel. 3 times negative 3 is negative 9, so negative 9 over 4. Negative 9. Oh, that is so ugly. I don't want to squeeze. Alright, so let me make it neater. So 3 pi over 2 times negative 3 over 2 pi equals negative 9 over 4. Okay. Now let's look at the pattern here. This is 3 over 4. This is negative 9 over 4. So if I were to make this into a common denominator of 4, this is 6. Would you agree? So negative 6 over 4. So it looks like I'm just going to add negative 3/4 each time to get to the next one. Okay, so even without doing the math, I can add negative 3/4 over this one. It's going to be a negative 12 over 4, which is really a negative 3. So these are my outputs right here. Okay, I'm sorry, my inputs. Oh man, all of those are negative, but look at my cycle. I have a positive thing here. Alright, so I'm just gonna go and extend this. Okay, I'm just gonna make this negative. Okay, so I'm gonna do a negative 3 there. And so what I'm gonna do is I'm gonna graph a cycle on the left, which we have not done, and a cycle on the right. Because remember, all you need is 2 full cycles. It can be left or right as long as you give me 2 full cycles. Alright. 0 times 3 over 5 is 0. 0 plus 2 is 2. 1 times 3 over 5 is 3 over 5 plus 2. So here's how we do the math. Okay. 3. Why am I saying 3 over 5? 5 over 3. My apologies. 5 over 3 is 1 and 2/3 plus 2. So that's really 3 and 2/3. And that's my output. Excuse me. 5 over 3 times 0 is 0 plus 2 is 2. 5 over 3 times negative 1 is negative 5 over 3. But if I were to put in mixed number, it's really negative 1 and 2/3 plus 2. Negative 1 and 2/3 plus 2 is going to be a positive 1/3. Okay, that's the output. And last one, 5 over 3 times 0 is 0 plus 2 is 2. So that's my last output. Let's count to see if I have 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so those are my outputs. I hope you can see them. Alright, and if I'm going too fast, please just hit pause, and then that way you can write it all down before I go further. And then it's like, if you don't understand what I'm talking about, it doesn't really help you. Okay, so make sure you pause, listen to it again, try to understand what I'm trying to say. So let's plot 0, 2. So let me go up 2 units. So 0, 2. Negative 3/4, which is 1 tick mark. It's 3/4. So negative 3/4, comma 3 and 2/3. So I need to do a couple more tick marks above. Alright. You can always expand this. Don't be scared. Negative 3/4 between 2, so 3 and 2/3. So negative 3/4, 1, 2, 3 up here. Negative 3.5, which is really 1 tick mark over. I'm going to go to 2. 9 over 4, comma 1/3, which is 1 tick mark over. 1/3 is a third of the way, right? Negative 3, go back up at 2. Okay, so here is my sine function arrow here. Notice how, oh, that is so ugly, isn't it? Alright, let's fix that. I want to make it smooth and continuous. Alright, so that's 1 full cycle on the left because we've reflected it about the y-axis. That's why it's now on the left. I'm going to graph 1 cycle on the right, so I'm just going to repeat. So this is now my middle. Notice how my middle is lifted up 2 units because this is a vertical shift of 2 units. So instead of being on the x-axis, it's now move up 2. So the next tick mark over, I'm going to be at 1/3. The next tick mark over is at 2. The next tick mark over is going to be this high value over here at 2 and 2/3, right? The next tick mark over is back at 2, and that is second cycle. You know, this is one ugly graph. Hopefully you are having a better sine curve than I do at this point. Okay, so that's 2 not so good looking sine curve. Since I already have this kind of label, I'm just going to continue. Alright, so 1/3, 2, 3 and 2/3, back to 2, and looks like that's where I'm going to stop. I don't have to do this third cycle, but just because I already have it labeled, you might as well use it. That's how I see it. So last piece is your domain, which is going to be all reals. And your range is going to be from, let's talk about my low. My low is at third. And my high is I'm going all the way to the top, which is 2 and 2/3. No, I'm sorry, 3 and 2/3. And that is my final solution. Okay, so I just want to remind you, don't forget to go back and complete C on your own, okay? I know if you don't do it now, you're going to forget, so just do it now. Have a wonderful day.